So let's start this video. In this video, I'll try to explain why transformation is lazy or why Spark follows lazy evolution. In this video, I'll give you some example, practical example. Using that, we'll try to understand why Spark is lazy. So let's think we have a problem statement that we have to load 4 GB file in our Spark cluster, and we have to print fast line, only fast line. Okay, you have to load this 4 GB file in our cluster and you have to print this fast line. And let's think Spark is not lazy, then what will happen? And then we will see if the Spark is lazy, then what will happen. So first scenario, Spark is not lazy, so it will load text file, it will load text file, and it will try to read it, and it will try to print it. Okay, like for each function, or like I am writing pseudocode. Okay, I am writing a pseudocode, not exact code. Okay, for each println, or you can in Python you can do for x in this rdd.take1. Okay, that you can do. So that will happen. So if the Spark is not lazy, it will load whole this 4 GB file in our rdd1, and it will just print fast line. Okay, just print fast line. So it will loading 4 GB file and only display fast record of the data. So we bought 4 GB data in our memory just to print fast line. How fair is it? Is it fair? No, it is not fair, because we brought 4 GB file to print one single statement, single line, so fast statement. That is not okay. That is not right thing. So if the transformation is lazy, if the now transformation is lazy, what will happen? Spark, when we are writing this statement, Spark will not do anything. Okay, Spark will only make one entry into DAG in the background. Okay, so until this point, Spark did nothing. Only an entry into DAG has been made in background. So there is one DAG entry. The Spark is lazy. There is a DAG created. Okay, we have to load. We have to load. Then when we Spark engine hitting this, reading this line. Okay, rdd1.take.print this one. So now Spark engine will start loading the actual data and display the fast record. The one catch is here. Okay, one catch is here. In this, when Spark is lazy, we are not loading 2 GB file. Okay, we are not loading 4 GB file. When Spark is lazy, we will load only fast record, because we know we have to print. After hitting this action, this take action, we will start loading our actual data. Spark will load. Spark is smart enough. Okay, Spark will do optimization itself. So something, what the main important thing, Spark can optimize like some part of some basic part. Okay, Spark can optimize our code in some point. Up to some point, Spark can optimize our code. So when we are printing this only single statement, Spark will understand that I don't have to load whole 4 GB file to print this single statement, and Spark will load only fast statement. It will load only fast statement, then it will print it. If Spark is not lazy, then it don't know, because if the Spark is not lazy, it will not wait for this action statement. When Spark is seeing this statement, loads text file, it will load those 4 GB file, and then at the last it will try to print it. But we know Spark is lazy, and it will know that we have to print only single statement. It will wait up to last. It will wait up to this action statement, and when in the action statement it is saying we have to print only single statement, it will load only signal statement. That optimization is providing by Spark, okay? And that is the one benefit of laziness of the Spark. Why term Spark is lazy? So in the lazy evolution, Spark know that it has to print only fast record. So it will bring only fast record into memory rather than loading entire 4 GB of data. And this better optimization is providing by Spark engine itself. It doesn't mean we don't have to do optimize our code. We have to do optimize our code. But in certain point, Spark can optimize by its himself. So another example, this is example one, and I think there is another scenario. Okay, we are loading, we are loading, we are loading one, we are loading one. What I can say, one we are loading a file, load a file that is content 2 lakh rows. Okay, 2 lakh rows. Load a file with just load a file which containing 2 lakh rows and do some map filtration and do some do some do some map filter map and filter operation. At last print final output. So load data so load a file with 2 lakh rows which contain 2 lakh rows and do some map and filter operation and print our final output. That is our statement requirement. If consider Spark is not lazy, so Spark is not lazy. Consider this scenario. When Spark is not lazy, what will happen? RDD1 load the text file. The text file will and then RDD2 equal to RDD1 dot map will thing happen. Then RDD3 equal to RDD2 dot filter. Then for x in RDD3 that collect print x. So we'll try to print. So here we are loading that file with 2 lakh rows, then doing some map operation, doing filter operation, and try to print this line. Let's think we are doing some map operation, then we are filtering 20 lines. Okay. So they just when I loading this file, there is 2 lakh rows, 2 lakh rows. Okay, and here we are doing some map operation on top of 2 lakh rows. Then we are filtering this 2 lakh rows, and after filtering we are getting only 10 lines. Okay, so we are filtering on 2 lakh rows and getting only 10 lines, 10 rows, and then just printing 10 rows. So when Spark is not lazy, so it will start execution from start. It will load the 2 lakh files, and it will do map operation on top of this 2 lakh rows, and after filter we'll get some 10 rows or 10 lines from this 2 lakh rows, and printing this 10 rows at last. Is this correct way to doing this problem? Because for printing 10 lines, we are just loading all whole file with 2 lakh rows. That is not a right way. This is the big data. Okay, this is not small data. When you are transferring data, each involve cost, it takes space, and that is not a good for some company, because if you are loading some unnecessary data, it is a burden for company. It is, so they have to, if everybody is doing like this, they have to like expand, they have to increase their storage space. So that is not good thing. Okay, if some company is working on cloud, so for every data transformation they have to pay money to AWS or Azure or cloud. So they have to pay money for every data transformation. So if you are transferring data from somewhere to some, from your local to your cloud, let's think, and then you're doing this operation in our cloud system. So you are unnecessarily loading this 2 lakh rows. It will cost huge money to that company. It is not right way, and this is also not a sustainable way. Okay, when the Spark is not lazy. To solve this problem, to Spark solve this problem, we can do this filter operation above. Okay, so if you want to optimize your code, so I can do filter this operation above, and then we can do map operation. Okay, so we can skip lot of processing step. Here we are doing some processing. We are processing some 2 lakh maps, 2 lakh rows. But we can, if you want to avoid these processing steps, we can filter these lines above. Then we can do a map thing later. Also, it will save time, and also we'll get this result as a fast. Okay, we'll get this result as a less time. So exactly that will do Spark. Okay, if that Spark is not lazy, to solve this issue, Spark will do exactly these things. Okay, so our code is not lazy now. Okay, our Spark is lazy now. So is then when we are writing this and this and this, it will not do anything. Okay, it will just make some entry on the DAC. And when we are hitting our action statement, then it will try to execute this operation. Okay, and Spark will optimize our code. If I also if we writing code like this, okay, this first map then filter, Spark will to optimize internally, so that it will make this filter above and map here. It means, so it will try to filter, it will try to only load those 25. Okay, so Spark will try to optimize the process to reduce the execution time and number of operation. That the main motive of that Spark. Okay, it every time itself try to optimize our code, and it will give a solution that if you write like this, Spark will optimize your code. It will do like this. It will, if I write like this, when Spark is lazy, Spark automatically optimize it, and it will do like this. RDD 1 load text file. then RDD 2 RDD 1 dot. So it will reshuffle our code. And that's the benefit when the Spark is lazy. RDD 2 map RDD 3 for each. For what is it? For each means for all you, what you want. For x equal to for each in scala. If you want to print in Python, you have to do like this RDD 3 dot collect. Okay. So it will do like this. So Spark will bring filter operation up, this filter operation up and map down. Okay. Before filter is here, now filter is here. So before filter is in the above, you can see filter is here. Okay. Now Spark will move it to upper section and it will try to drop down. It will try to put down this map below. So it will disable it. So that's how Spark is that's how Spark will do optimization when Spark is following lazy evolution. And that is the benefit. That's why Spark is lazy. That's why Spark is that is transformation is lazy. When this transformation and Spark is lazy, we will get this benefit. Otherwise, we will not get this benefit. Because when the Spark is not lazy, it is act like a normal program. If you are writing some Python program, it will try to execute step by step. It will not give some optimization. Python interpreter will not give some optimization because what you are wrote in your code, it will give some exact. It will follow some that exact steps. It will not do some optimization internally to give you better to reduce your execution time. But Spark will do because it is lazy. Spark is designed in a such a way so that it reduce our number of operation and time to execution. So Spark always try to reduce these things, number of operation, number of time, so that it will give you result faster way, in faster manner, in less time. And once again I will try to repeat, execution will not start until an action is triggered. Okay, execution is not start until an action is triggered. Data is not loaded until it's necessary. One thing you should remember, data will not load. You can write std.txt file, but it will not load until it is necessary. And Spark maintain the record of the operation through DAC and better optimization by Spark engine. So I am repeating this key point. Execution will not start until an action is triggered. Data is not loaded until it is necessary. Also, Spark maintains the records of the operation through DAC. And at last, Spark will provide some better optimization, and that work will do by Spark engine. So optimization will provide by Spark engine internally. Okay, some point up to some point. And Spark code can be written in 4 languages. Okay, we can code Spark code can be written in 4 languages. One is Scala, one is Java, third is Python, R. So this R, mostly data science guy will follow this. Okay, but our preference will be Python. Okay, and some point of Scala. Up to some point, I will show you the Scala code. So that's the end of the video. I hope now you are clear why Spark is lazy. And I think you will not get this type of example in YouTube. It is a crystal clear example. Okay. And one thing I want to say, Scala is a number one choice. Okay, for Spark. Okay, because Spark itself is written in Scala. Okay, internally Spark is written by Scala. Okay, so internally Scala is used in Spark. Okay, And also because Spark internally Spark itself written in Scala language, and that's why it is give you a best performance, because internally Spark is written by Scala, so it will give the better performance than Python. If you are writing code, Spark code using Python, and same you are writing Spark code using Scala, you will get better performance here. That's it in this video. Thank you. Here we are following some API to write PySpark code. So when you're writing code using Python, there is some API which converting our Python code to the Scala code internally. That's why it is taking some time, extra time than Scala. Scala is internally embedded with Spark, so that is not it is not taking extra time. But in Python, we are via some API we are trying to write code. Okay, we are writing Python code in Python, but our Python code is converted to Spark code, to Scala's code. That's why we are that's why it's taking more time in Python. That is my understanding. So thanks. Now you can also research about it in website. There is a good website called, I know, I think what is the website? I think there's a Spark official documentation is there. It is too good. Okay, it is not like other documentation. It is crystal clear. Everything is written in example. Okay, with example. Please go through the Spark official documentation. It is like sparkapache.org. It is very good documentation. I hate documentation, but this Spark documentation is one of the best documentation. You will not find any better documentation like this. It is too uh, too crystal clear. It is explained in well manner. Okay, they'll give some example. Okay, then they will try to explain. So for every step they will give some example. They will give some Python code or Scala code, and they will show you some output also. Step by step they explain like in a good way. So I will tell you, just I'll so just go through this Spark uh, org documentation. This I should follow. This is one of the best documentation, I will say. This here you can find PySpark also. Okay, just PySpark documentation. This one of the best documentation, I will say. Best. Okay, they are explained in very good way. One of the best documentation. Just go through this. What is transformation? What is identity? Everything there. Crystal clear. Just search like RDD PySpark official doc. With this step by everything about identity they mentioned. Okay, just go through this growth, go through this documentation. Your concept will be crystal clear. Thanks for watching this video. I think you are able to understand this concept of Spark, why Spark is logic. Bye. Thank you. Thank you for